Hi, my name is Alan Campopiano. I'm an EEG technician at the Brock University Cognitive and Affective Neuroscience Lab. I've written a statistical software program called STATSLAB, which performs the percentile bootstrap test using trim means on EEG data. In this video, I'm going to give you a brief walkthrough of STATSLAB. Okay, so under the YouTube video, you'll see a number of links. One link is to the STATSLAB wiki, which gives some more information on the toolbox, as well as a literature review on percentile bootstrap and trim means and why we might prefer those methods over conventional statistical approaches like t-tests, f-tests, Pearson R, and so on and so forth. So have a look. There's also a wiki to the STATSLAB software itself, so just click the download zip button there to get the software. You'll also need to download EEG Lab. I've left a link there for you. And there's also a Google Drive link under the video for the tutorial data so you can follow along with exactly what I'm doing. So let's get started. I'm in MATLAB and I'm inside of the STATSLAB tutorial data. I've set my path to that folder and everything underneath it. You will see 3 folders. Each one of those represents an analysis that we want to use STATSLAB for. I've also created a 4th folder which contains my dependencies. So it contains STATSLAB as well as EEG Lab. So to begin, let's go inside of scalp FCZ. So this is the folder where we're going to conduct a simple analysis using scalp data at FCZ, and you'll see a number of data files in here and a couple of other files that you don't have to worry about. So the data files are the .set and .fdt files. There are data files for 3 subjects in 2 conditions, and the 2 conditions are go and no go. Okay, so to get started, just type in STATSLAB. This brings up the main STATSLAB GUI, and STATSLAB is arranged in modules. So the first module is extract data, second is resample data, group statistics, group figure, subject figure, and then a couple of correlation modules, which we're not going to worry about. The modules are meant to be run sequentially. So in this first module, extract data, we're going to extract the appropriate data from the set files that are sitting in our current directory. And the idea with this GUI is that you just want to fill in all of these fields with the appropriate statistical parameters or the information relevant to your design or your analysis. So let's begin, and I'm just going to fly through here. So one of the nice things about STATSLAB is that if you want to know what STATSLAB is expecting you to write in these fields, all you have to do is click on the field and read below. So this is looking for condition names. So hit the side of the field there to bring up this little box, and we're going to put our condition names in: go, no go. And let's keep filling this out. Condition files. This one you can leave empty, and MATLAB will bring up a window for us to manually select condition files. Levels. So in this case, this is levels denotes each factor in your design, the levels for each factor in your design. So if we had a 2 by 2, we would just say 2 space 2, or 2 space 3 if we had a 2 by 3. But we have a 2 basically. In this is just sort of like a paired t-test example. We have 2 conditions, so it's not factorial, so 2. Design, you can read the documentation. We have a 1-factor design that's fully within subjects. And save string is a unique identifier, a word or a phrase that helps you identify your analysis. So in this case, we could just call it go. It doesn't matter. It can be called whatever you want as long as it makes sense to you. Go, no go, scalp, FCZ, for example. Great. var argin stands for variable argument in, and it controls all of the optional inputs. So there's a lot of them, and obviously I can't go through all of them, but I'm going to show you the most basic set of optional inputs for extract data. So we want some kind of measure. Which measure? Scalp chan. So var argin values are always entered in word pairs. Measure goes with scalp chan. Chans. Which channels do we want? Well, you could specify channels like this. If you wanted to, separated by a space, or FCZ, CZ, something like that. You can also give it keywords like per subject, which will allow you to graphically select channels on a per subject basis. And that's all we have to do. And you can read the documentation to see what other options STATSLAB has to offer there. There's lots. Okay, so that's good. And this module is completely filled out. So you can click this button here, which means that after you click OK, it will actually run extract data. And that's fine. You can run each module separately if you want. But to speed things up, I'm just going to continue to fill out the rest of these fields. And as a matter of fact, whenever you start filling out these fields and you're happy with how it's filled out, you can actually save the fields. So I could save everything I've done. Say I want to save it with the file name myparams. Then the next time I open up STATSLAB, I can just load those parameters and everything will be populated again, and I won't have to write all of this out again. Now, I'm actually going to load a parameter file that I've made ahead of time, just to save some time here, and everything's all filled out. So this is really how you should use STATSLAB, is fill out everything once, click all the run boxes, and then click OK. So we're good with extract data. That looks great. Let's click the run box, and I'll explain very quickly the rest of the modules. Then we'll run it, and we'll get to see some visualizations of our data. Resample data is where the bootstrapping surrogates are constructed. Con files, again, we can leave that empty and pick files manually. Number of bootstrap samples, or nboot, this should be a high number like 1,000 or 5,000, but I'm going to leave it as 50 for the sake of the demo. Trim, this is referring to the trimmed mean, the percentage of values that you want to trim from each tail of the distribution. You can read the documentation or the wiki, or just Google trim mean if you want to learn more about how that works. var again are the optional inputs again, and in this case I'm going to leave it as trial cap none. Don't worry about what that means. You can read the documentation to find out more. And that resample module is done, so I'm going to click the run box. Now let's move on to group statistics. As usual, we can leave con files or condition files empty, and we'll manually be prompted to load those files. Alpha, that's self-explanatory, and here we are at the optional inputs. Family-wise error, FWE. STATSLAB has a number of options for controlling for family-wise error. In this case, I've chosen not to control for family-wise error, so FWE none. And then con A with its pair, with its value here, just controls exactly which conditions you're comparing. So con A stands for contrast for factor A. This is not a factorial design, so we only have one factor, so we call it A, factor A, or contrast A. And this is a contrast matrix, or a set of contrast coefficients, which again tells STATSLAB which conditions do we want to compare. In this case, again, we only have two conditions, so we're gonna actually compare go to no go, or go minus go. And these contrast coefficients can get a lot more complicated whenever we have a factorial design, and we'll get to that example later, but for now, this is sort of the easiest, the most simple way to set up a contrast coefficients. So that looks great. Run group statistics, yes, we'll check that box, and then we can come down here, and all of these for the single subject statistics are all filled out perfectly. They don't need to change at all. We'll click this run box, and now we're at the figure modules. Okay, you don't have to worry about info display, but let's get to var again. All means that I want to plot all figures. I want to plot a figure for each contrast that I've specified in the contrast matrix. But we only have one contrast, so all really just means plot the one figure. Time plot, this is the x-axis range that we want to plot, so we want to plot from -200 milliseconds to 600. And topos, with its value, this means that we would like to look at topographies and we have to give a channel locations file to do that, to produce the right topography files. So that looks great. Let's click that run box, and then eventually we'll be able to see a group figure, and then we'll open up STATSLAB again, and I'll show you how to look at the single subject figure so you can see what happens when we have to load it up again. Okay, this all looks good. So normally, of course, having filled all these out, then you would save them all. I've already got mine saved, so I'm not going to bother doing that. So let's run it. Okay, so we're inside of extract data module, and it's asking for go condition files. Go, go, go. No go, no go, no go. And you can read the top of the windows. It'll always tell you what to do. Okay. This GUI comes up because we specified that we wanted to pick channels on a per subject basis. So in STATSLAB, you can just click on the channels that you want to do statistics on, or click them again if you change your mind. If I wanted to do statistics on A11, I could click A11 and say apply that to all the subjects. When you do that, STATSLAB checks for internal consistency to make sure that all the subjects have those channels. If it detects that someone doesn't have that channel, it will give you a warning. We'll say review subject by condition index 2.1. So let's go there and see what's going on. Second subject in the first condition, enter, and we see that that person does not have A11. So this is not going to work. We're not actually interested in A11. We want something around FCZ. So let's pick C12. We'll say apply to all. It does, and you can see in the command line that there's no warnings. So that's awesome. So let's hit OK, and it will run extract data. So now it's taking C12 out of all of those set files. Now we're in the second module, resample data, and it's asking us to select all of the files that we wish to bootstrap. So all of the output files will have underscore extracted appended to them, and those are the files that were the output from extract data, and now they're the input to resample data. So there we go. That looks good. So now it's bootstrapping, and now it's done bootstrapping. Now we're in the group statistics module, and it's going to ask us to pick the files for each condition. So pick the files in the bootstrap files in the go condition. So go bootstrapped, go bootstrapped, go bootstrapped. Pick the bootstrap files in the no-go condition. No-go bootstrap, no-go bootstrap, no-go bootstrap. Now it's doing single, so it's completed the group statistics. Now we're into the single subject statistics module, and we'll do the same thing. Go bootstrap, go bootstrap, go bootstrapped. No-go bootstrap, no-go bootstrap, no-go bootstrap. And now it's doing the single subject statistics. There's only 3 subjects, so it doesn't take too long. Now it's computing topographies. And now it just plotted the group figure. So we have red, go, blue, no go. It's red minus blue, or go minus no go. And in the bottom section, we see the difference wave with the confidence interval. At any latency, you can click to get back the topographies at that time. And that's pretty cool. And there we go. That is how you go all the way through STATSLAB with a basic analysis to plot a group figure. Let's go back into it though and plot the single subject figure. I'll load my parameters. As I said, you wouldn't want to type all of that in again. So let's just load the parameters, go down to subject figure, and we'll click this run box. I'll explain the options. We want to plot all of the figures in our design, or all of the, we want to make a figure for all of the contrasts in our design. Which kind of plot do we want to make? There are several options which you can read about. Let's pick the simplest one, which is just a difference wave. We'll use the same time plot, and this time we'll say topos, no, because we already computed topos, so you only need to do that once. You'll see what I mean. So let's run it, and now we get data, a difference wave for each subject. So go minus no go for each subject, and again you can click on any latency and get topographies. Subject 1, subject 3, so on and so forth. Okay, So that's one full analysis just using a scalp channel. Okay. Now let's step it up one notch, and we will do basically the same analysis, but we'll actually extract independent components from the data. Okay, so let's go into ICA-FCZ and call up STATSLAB. Load the parameter file that I have in there. Most of this is exactly the same as the last set of parameters that we used, except that the save string, of course, is different because we want to make it something unique, and there are some different options which, of course, specify that we want to extract independent components and project them to a particular channel. So instead of measure scalp chan, we have measure ICA scalp, okay, and then which ICs we want to pick them per subject, and which chans, again, we want to pick per subject. Okay, so we can run that. That's good. Resample data, we'll keep that exactly the same. Group statistics, exactly the same. Subject statistics, same. Group figure, same. And we'll run that. We'll just take it right up to the group figure. Okay, and then we want to, of course, click these checkboxes so that it actually runs those modules. And I think I have all of the ones I want for right now. So let's hit OK and see what happens. Okay, so go condition set file, go. Sorry, go, 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 no go, no go, no go. This GUI you haven't seen yet. This GUI just allows you to put the indices for the ICs or the independent components that you want to extract for each subject. I know these numbers because I've explored my data in EEG Lab, and so having explored it, I know which ICs I want to use for each subject. Of course, you can save this array so that if you ever have to do this module again, you don't have to type these numbers in. But everything looks good, so I'll click OK. Here's a familiar GUI. Again, it's asking basically at this point, which channel do you want to project these ICs to? Let's go C13 again, or I think it was actually C12. We'll say apply to all, look into the command window, and there's no warning, so everybody has that channel. We'll click OK, and it will start to take the set files and reduce the data to those independent components and then project them back to that channel. And now we have some extracted channels. So select the files you wish to bootstrap. Everything with _ extracted, those are the files that we want. Whenever you run extract data on independent components like we just did, STATSLAB will also give you these res extracted files, which are the residuals, which you probably would want to do statistics on the residuals as well. But for the sake of the demo, let's just use the ICs of interest. So here we have all of our files. Let's bootstrap those. Beautiful. So we're done bootstrapping. Now we're at the group statistics module. Go bootstrapped, go bootstrapped, go bootstrapped, go bootstrapped, go bootstrapped. Okay. No go bootstrapped, no go bootstrapped, no go bootstrapped. Now, obviously, you have to be very careful which files you're selecting, which files are going to end up in the statistics, but STATSLAB saves all of the things that you're doing. So it saves all of these file names. So you can always go back as a sanity check and double check that you actually selected the files that you wanted to select. Okay, so open. Okay, so now it just finished doing the group statistics. So that's great. Now we're in the subject statistics module and we'll do the same thing. Go bootstrapped, go bootstrapped, go bootstrapped. And no go bootstrapped, no go bootstrapped, no go bootstrapped. Okay, now it's running the single subject statistics. Now it's calculating topographies. And now it's plotted the group figure. Again, we have our condition waveforms, our difference wave with a confidence interval, and we can plot topographies at any latency. Great. So one last thing. Let's look at an interesting visualization of the single subject data as well. I'm going to load my parameters file and then go down to subject figure and run just this module, only this time instead of choosing the wave plot type, I'm going to actually choose something that's pretty fun. CIMO, which stands for confidence interval margin of error. Okay, and then there's a couple of other pairs of options that control how all of the axes look. Okay, and you can read about that in the documentation. Okay, and again, topo's no, because we already did it once. Okay, so I think that's good. Let's run it. Awesome. So this is CIMO, or confidence interval margin of error plot, where the color bar here represents the mean difference between go and no-go for each subject. Okay, so around here where my mouse is, the difference is about 0, but you can see it goes up on the y-axis to about 1, and all of that means is that the confidence interval, or the range of values around this difference of 0 can range from plus or minus 1 microvolt. Okay, so let me say that again. You have a difference of about 0, and that difference can fluctuate from about plus or minus 1 microvolt. Okay, and likewise, if we went up here towards the middle where there's a larger effect, okay, let's say that that's around 2 microvolts. Okay, 2 microvolts plus or minus about another 2 microvolts, because it's at the level of 2 on the y-axis. So this just gives you some visualization of the confidence interval. Okay, and the reason I have this, and there's a number of visualizations you can use for single subjects, is because if you have, say, 30 subjects in your study, plotting it with the wave option like we did before, that is it's not very clear when you have that many subjects. It's the waves, you can't see the effects quite as clear. So this is a good alternative to that, and there are others. And these black lines here are just the p-values, so they show whether or not there's a statistical effect at alpha. And of course, you can click on these to get the topographies, just like before. Okay, great. So that's 2/3 of the tutorial done. Let's go to the very last analysis, the ICA-ERSP FCZ factorial analysis, and we'll step it up one more notch. So one of the differences here, so the goal here for this analysis is we want to use ICA just like we did in the previous analysis, but now we want to actually calculate a time frequency measure. We want to calculate event-related spectral perturbation. We want to project those ICs to FCZ, and this is a factorial design. So a few things about how we set up the STATSLAB main GUI, the main STATSLAB GUI, a few things will be different, and I'll go through that. One thing you need to know about the data files themselves is, again, we have 3 subjects, but now we have 4 conditions. Because it's factorial, we actually have go, no-go, sleepy, and go, no-go, alert. Okay, so let me show you. I'll bring up STATSLAB. And of course, I've already made a parameters file just to save some time. So let's load the parameters. Okay, now you can see one of the things that's changed for this analysis is the condition labels. So I've just given them the labels go alert, no go alert, go sleepy, no go sleepy. So this is a factorial design. And we'll leave conf files empty. This is a 2x2 design, so we have 2 factors and they each have 2 levels. This is a WW, which means it's 2 factors and each factor is within subjects. I've given it a new appropriate save string. Okay, and there of course are some other options that we need to specify. So measure, which measure? ICA-ERSP. Chans, which chans? Let's go per subject again. And ICs, which ICs? Let's go ICs per subject. So that one's ready to go. Nothing about resample data needs to change. But of course, once you get to the optional inputs for group statistics, you'll see that things are a little bit different. So family-wise error, I'm just going to specify none again. but now you have more complicated contrast matrices. So for factor A, contrast A, we would like to compare condition 1 to condition 3, and then delimited with a semicolon. The next contrast for that factor is we would like to compare conditions 2 to condition 4. So for factor A, we're specifying that we want to make 2 comparisons. We would like to compare condition 1 to condition 3. So that's go alert compared to go sleepy. And the second contrast is no go alert compared to no go sleepy. Then we also have comparisons for factor B. So here we want to compare condition 1 to condition 2, and the second contrast for that factor is comparing condition 3 to condition 4. Finally, we have the interaction contrast coefficients, which are 1, -1, -1, 1. That basically amounts to the difference of the differences, and I'll let you research contrast coefficients if you want to learn more about that. So that's how that works. Everything's good with that. And the same exact setup for single subject statistics, and we can run that. And let's just go group figure, and we'll just run the group figure for now. Okay, and let's go for it. I think everything looks good. Okay, so select files in the go alert condition. Okay, go alert, go alert, go alert. Select files in the no go alert condition. No go alert, no go alert, no go alert. Select files in the go sleepy condition. Go sleepy, go sleepy, go sleepy. And select files in the no go sleepy condition. No go sleepy, no go sleepy, no go sleepy. Here's the independent components GUI again, where we can put the indices for the ICs that we would like. I'll just add them in here quickly. Okay, good. Of course, here is the channel picker again. We know C12's pretty good option. Apply to all. There is no there's no warnings, so that's good. Everybody has that channel. Let's go OK. And now it's taking C12 out because because later we want to calculate ERSP on it. So we have to wait for this to finish. It's done. Now we're into the resampling section, and we will pick all of the underscore extracted files. Keep in mind that all of these little windows that come up that ask us to select files, this only ever has to be done once. If you ever have to run the module again, all of that information is saved, and so you don't have to do it again. Okay, those are the files we want to bootstrap. Okay, so now this is going to take a couple of minutes, and I'm just going to wait for it. Oh yeah, I should also mention that for any of the time frequency measures, there are some other optional inputs that can control how the time frequency decomposition is calculated, like which frequency bands you want to look at, and so on and so forth. That's all in the documentation. The reason why I didn't specify any of those is because I didn't need to, because there's some default options that STATSLAB uses which I know work in this case, and I like them as a general rule. So you can read the documentation about that if you want more control over the time frequency decomposition. So I'm just going to wait now. Okay, so we have finished resampling and now we're in the group statistics module. So what does it want? Bootstrap files and then go alert condition. Okay, go alert, go alert, go alert. I think I got them all. And now it wants the bootstrap files in the no-go alert, no-go alert, no-go alert, no-go alert. Good. Go sleepy, go sleepy, go sleepy, go sleepy. And finally, no go sleepy, no go sleepy, no go sleepy. So now it's calculating statistics at the group level, but of course it has to do the bootstrap statistics on all of the frequency bands from 3 to 30. So that's why it's out of 27 there at the top bar. So I'll just wait for this to finish. Great. So statistics at the group level is finished. Now we're at the single subject level and we'll do the same thing. So go alert, go alert, go alert. No go alert, no go alert, no go alert. Go sleepy, go sleepy, go sleepy. And no go sleepy, no go sleepy, no go sleepy. Okay, so now it's calculating the bootstrap statistics on the time frequency decompositions, but it's doing that for each subject. So 1 out of 3, of course, it's only 3 subjects. Great, so it finished calculating the single subject statistics and now it has plotted the group level figures. And let me arrange these for you and explain what you're looking at. Okay. We specified 5 contrasts in total, 2 for factor A, 2 for factor B, plus the interaction. So at the top, you have the 2 factor A contrasts, and at the bottom you have the 2 factor B contrasts, and then here on the side you have the interaction. Let me explain what you're looking at. Over here in the top left, basically we have the ERSP, event-related spectral perturbation, for frequencies 3 to 30 across time for the go alert condition, and then in the second panel we have the go sleepy condition, and then the third panel we have the difference between the 2 of those conditions. And then in the last panel, anything that's black is a p-value, is a statistically significant p-value at alpha. Okay, and we have that for all of the different contrasts that we made. So there's no significant, no statistical differences in that for that particular contrast. And we go here, we're now comparing no-go alert to no-go sleepy. So we see some alpha, mostly alpha. ERSP effects, okay? And then we can go to the third one. We have go alert minus no go alert. Again, we have a pretty large effect that's alpha and beyond. And finally, well, second to last, we have go sleepy versus no go sleepy. Okay, and then we have an effect that seems a little bit well, it doesn't have as broad of a spectral spread as the previous figure. So So that's what's going on with those figures. And then we finally have the interaction, where again you have the frequencies on the y-axis, the same time scale on the x-axis, and instead of showing condition waveforms, we just show the difference. So this plot that you're looking at here for the interaction, this is the difference of the differences. Okay, so it's go alert minus no go alert minus go sleepy minus no go sleepy. The difference of the differences. That's basically what the interaction is. Okay, now the little Easter egg for these figures is that if you would like to see the confidence interval information for any frequency band, you can simply click on the difference panel. So here I'm at go sleepy minus no go sleepy, and you can click on that and actually get an interval for whichever frequency band you're clicking on. So in this case, my mouse clicked at about 6 Hertz, and here's a confidence interval around the difference for that frequency band, and you can see the condition labels up here and the frequency. And you can do that for anything you want and always get confidence intervals. Okay, so there you go. Now we're almost done. The last thing to do is to do the spectral plots, but at the single subject level. So let me load the parameters again. I think this is it. We'll go down to subject figure, and now we'll plot a subject figure, and we'll see what that looks like. Okay. Good. So it's very similar to what I showed you before, only this time the p-value panel looks a little bit different. Okay. All of the rest of the panels, the top 3 panels for each of the figure windows, are exactly the same as what they were at the group level. In fact, it's group data. But the p-value areas, they show something different. Rather than showing significant p-values, they show a proportion of subjects at that frequency at that time who had a significant effect. So for example, red, we only have 3 subjects. So red is 2/3 of the subjects, yellow is only 1 subject, white is no subjects, and black, which you see down here, are all 3 subjects. So if you see black, it means at that frequency and at that time, all 3 subjects had a significant difference between those 2 conditions. Okay, so this is quite interesting. And of course, again, the little Easter egg is if you click on the difference waves, now you can actually verify that. So I'm clicking here at about 5 Hertz, and indeed you can see that 2 out of the 3 subjects had a significant difference at that frequency across time. Okay, so that's pretty cool. And if you were to click on, so there's an effect here that seems to be shared by all 3 subjects. Let's click on this difference wave up here, and indeed all 3 subjects, we can see their confidence interval across time at 5 Hertz, and we can see the effect. Okay, but if I were to click, let's say, I don't know, like here, you can see no subjects are showing a significant difference. So that's consistent. And basically this is just to give you some idea of what's going on underneath the group data, right? Because sometimes the group data can be a little bit misleading. You don't know what's making up the group data all of the time. So this gives you a deeper look at the data. All right, that is everything. So thank you for following along. If you have any questions or comments, feel free to write me a note on the YouTube video or get into contact with me any way you can, and I'd be happy to help out if you're interested in using the toolbox. Thank you very much.